right, our next chapter is chapter number 4, force and movements. Here we can see force and movements is explained with the help of spanner. The longer the spanner, it is more having the turning impact. The longer the spanner, the greater the turning effect, which is the force. Spanners are used for tightening and loosening nuts. They help to produce a larger turning effect. What is the turning effect called as? The turning effect of a force is called a movement. The formula for movement of a force about a point is equals to force times perpendicular distance from the point. Movements can be described as clockwise or anti-clockwise, and the movement of a force is called as torque. The movement of a force is the turning effect of a force and called as torque. The movement of a force about any point is defined as movement is equals to force times perpendicular distance from the pivot. Hence we can write movement is equals to F times D. D is the distance, a perpendicular distance from the pivot. Its unit is Newton into meter. Here we have a concept of clockwise and anti-clockwise movement as well. Force F exerting an anti-clockwise movement through the spanner on the nut in this image. Movement can be clockwise or anti-clockwise. Here, Mia, movement turns seesaw anti-clockwise, whereas here, Amy, movement turns seesaw clockwise. We have an example over here. If we want to calculate the movement of an object X, given that it has two forces acting on it, the horizontal force is of 5 meter and vertical force is of 3. So we multiply them and we get our moment, which is 15 Newton anti-clockwise. Similarly, another object here is given with the force 5 Newton and the distance 4 meter. We multiply them and we get the movement, which is 20 clockwise. So the principle of movement is that we need the state of a balance. In order to be balanced, the clockwise forces must be equal to the anti-clockwise forces, and the balance form will be called as the state of equilibrium. What is the principle of movement? It states that an object in equilibrium, the sum of clockwise movement about any point will be equal to the sum of anti-clockwise movement. So sum of clockwise movement will be equals to the sum of anti-clockwise movements. So the principle of movement anti-clockwise, here we can see is 20 Newton, and the clockwise we can see 10 Newton. However, the distance here on the anti-clockwise movement is 1 meter, and on the other hand the distance is 2 meter. So if we want to calculate the movement, we have to just multiply force with the distance. So force 20 and distance 1 gives you 20 Newton per meter. Similarly, force 10 and distance 2 meters gives you the movement of 20 Newton per meter. We have some examples here. Similarly, the distance of an object we need to see, and the force which must be given to you. Hence, you can calculate the moment by multiplying the force times the distance. Force times the distance. Here, if we want to calculate a combined clockwise movement, the first one is having 5 Newton and the distance is 2 meters. The another one is 20 newtons and the distance is 0.5, and they both on the right hand side. So if we want to calculate the clockwise movement, we simply add them. The two forces, we will calculate them separately and add them, and we will get the total combined clockwise movement. Here on the trailer, we need to see what force is exerted on the hitching point and what force are on the rear tires on the road. So we can see here the center of mass is given here, and the distance from here on one side is 6, and from the object the distance on the another side is 3 meter. So at hitching point, the downward force of the trailer on the hitch is equal to the upward force of the hitch on the trailer. That's why it's standing. If it is not balanced, it will tilt. The downward force of the rear tires on the road is equals to the upward force of the road on the tire Y. Again, this is also balanced. So if we need to know that what force that the trailer exerts on the hitching point and what force do the rear tire exert on the road, we need to find X and Y. To find X, we can look at the moments about point B. So its clockwise movement is X times the distance. The distance is given, which is 9 meters, 6 plus 3. Then anti-clockwise, we can see we have the movement 400 Newton into 6 meters. So we have total of 2400 kilonewton meter. So now what we can do, X times this 9 meter is equals to 2400 kilonewton into meter. So if we want to calculate the X, 9 will simply go to the other side and divide, and we will get our X as 266.7 kilonewton. So the downward force hitching on the hitching point is 266.7 kilonewton. In order to calculate the Y, we need the upward force, which is equals to the downward force. The upward force is X plus Y and downward force is 400 kilonewton. We already know what is the value of X now, so by replacing X with the value, we can easily calculate our Y, which is calculated as 133.3 K Newton in this example. So, lots of tiny particles are here and they are exerting the gravitational force. The upward force is there, the suspension force is here. When the gravitational force on either sides of G are equal, the ruler is balanced. And the forces act now together at G, a resultant force, which is the weight. G is the center of mass or the center of gravity. In this diagram, you can see in the middle it is stable. This is unstable as not in the middle, and this is a neutral equilibrium. So, center of mass and stability. This is the point where we have the center of mass. Weight is always acting downwards, and there is always an upward force from the ground. The box here is in equilibrium, forces are balanced, as are the turning effects. Here you can see if a small force is applied, the tilt is small, the upward and downward forces will act to return the box to its original position. With a larger force applied, there is more tilt, the box goes beyond the center of gravity and it may fall. So, if a box has a wider base, the lower center of gravity, then it will be harder to tip over. With this, we have finished our this chapter. See you in our next chapter.